Okay, Assalamualaikum. Okay, Assalamualaikum dan selamat sejahtera. Okay, dengar tak? Dengar tak? Okay, so sekejap. Okay, cuba awak tengok, nampak tak skrin? Okay, boleh tolong respon tak? Skrin tu nampak tak? Sebab saya guna tablet ni. Nampak tak skrin? Okay, so today we are going to discuss about some important keys. Okay, actually this is the summarize of all chapters. Okay, so kita akan tengok chapter mana yang kita sempat. Okay, cuma saya nak awak respon nampak tak? Nampak tak nota yang saya sharekan? Okay. Okay, so for chapter 2, okay, so kita straightly discuss chapter 2. Okay, sebab saya nak tengok sejauh mana kita boleh habiskan discussion kita petang ni. Okay, for chapter 2, okay, for 2.1, so we have linear motion. Okay, so linear motion, look at here. Okay, so here we have, okay, so this one is instantaneous velocity, average velocity, and uniform velocity. Okay, jadi awak mesti tahu bagaimana nak bezakan ketiga-tiga ni. Boleh dengar saya tak? Boleh dengar tak? Boleh respon dekat ruangan komen Okay. Alright, so now when we look at to subtopic 2.1, so we have instantaneous velocity, average velocity, and uniform velocity. Okay, so what is the instantaneous velocity? So it's a velocity at a particular time. Okay, alright, so let's say we have equation. So for example, we have equation of x, okay, in terms of t, for example, okay, so we want to find what is the instantaneous velocity, okay, at t is equal to 2 seconds, for example, okay. So you must know that this equation, this is displacement equation. So you need to differentiate this equation first, okay. So as we know, v is equal to dx over dt, okay. Saya harap awak dengar sebab tak ada orang pun nak respon ni. Dengar tak? Okay, boleh dengar Okay, sorry, saya berperasan. Okay. Okay. Kalau ada apa-apa soalan, awak boleh tanya dekat ruangan komen tu ya. Okay, so for the average velocity, okay, you must know what is the average velocity. Okay, so tadi instantaneous velocity, if we differentiate the equation, so we have 4t plus 1. So bila kita cerita pasal instantaneous velocity at a particular time, so you need to substitute t equal to 2 seconds. And how about average velocity? The rate change of displacement. So V average, remember the equation is the rate change means that the change of displacement x final minus x initial over T final minus T initial. Okay? And velocity always constant when we have uniform velocity. Okay, velocity constant, uniform velocity. Apa lagi? Okay, velocity is the same all the time. Alright, next. So we have the instantaneous acceleration. You must know what is the difference between the instantaneous acceleration and the average acceleration, as well as uniform acceleration. Okay, remember uniform acceleration, okay, tengok sini, acceleration is always constant. Uniform acceleration bukan A is equal to 0. Okay, maknanya bila uniform acceleration, kalau diberi A is equal to 10 meter per second squared, okay, means that daripada 0 hingga 10 second, acceleration dia sama saja selama 10 second. That is uniform acceleration. Okay, but when we talk about velocity, velocity is constant. When the velocity is constant, baru you punya acceleration is equal to 0. Okay, boleh. Okay, you mesti tahu macam mana nak bezakan. And then, what is the instantaneous acceleration? Is the acceleration at a particular time. So, if we have the equation of V tadi, bila you differentiate equation V, you akan dapat equation of acceleration. Lepas tu, you boleh substitute. Okay, kita kena laju sikit. Sebabnya, saya nak tengok berapa banyak kita boleh cover petang ni, sehingga 4.30 insyaAllah. Okay, alright, so now how about gradient? We have three graph here, ST, VT, okay, and sorry, this one is area under the graph, VT graph, okay. So let's say we have gradient of graph ST, it's a velocity. Remember, baca soalan betul-betul, itu graph apa? ST ke VT, okay. So kalau gradient VT, dia adalah acceleration, okay. And area under the graph of VT must be displacement or distance. Okay, so sebelum saya teruskan lagi, saya nak ucapkan terima kasih kepada Puan Nina Farina binti Syahzarin, okay, daripada pensyarah fizik daripada Kolej Matrikulasi Johor, okay, yang telah share nota ni. Okay, jadi kalau anak-anak pelajar, awak semua nak nota ni, nanti di penghujung sesi saya akan berikan. Okay. Okay, saya akan bagi link kejap lagi. Alright, so now this is a graph of V against T graph. Okay, look at this graph. Okay, saya zoom sikit. Sorry. Okay, this one. Okay, so now look at this graph. We have V against T graph. Okay, so let's say from here, from 0 to 1 second. For example, this is 1 second. Okay, you must know how to interpret the graph. Awak mesti tahu, baca what kind of motion yang terlibat dalam graph tersebut. Okay, so from 0 to 1 second, tengok sini, from 0 to 1 second, what happened to the velocity? Bila kita tengok pada sini, what happened to the velocity? The velocity is not constant. Yang constant adalah dia punya gradient. Okay, gradient dia constant, yes. Okay, tapi velocity dia, velocity dia apa? Velocity dia meningkat, increasing. Okay, so the velocity is increasing in positive direction. Nampak sini? This is positive. So in positive direction, maknanya kereta tu tengah bergerak. Dalam 1 second, dia tengah bergerak in positive direction, which is to the right, for example. Okay, and the velocity is increasing. Okay, and what happened after 1 second? Okay, contoh kita letak sini 1, 2, 3. So from 1 to 3 second, what happened to the car? Okay, the velocity of the car, let's say lah saya letak sini 2, 4, 6. So 6 here. So from 1 to 3 second, what happened to the velocity of the car? So the velocity of the car here, V here is constant. Okay, ini awak kena tahu chapter 2, graph. Okay, so here V is increasing in positive direction, here V is constant. So bila V is constant, yes, now A is equal to 0. Okay, kalau dekat sini tadi, A is not equal to 0, A is uniform. The acceleration is uniform. Okay, and how about this one? Look at here. Okay, look at here. Okay, the acceleration also uniform acceleration, tapi dia punya gradient adalah negative value. Okay, ini adalah A, but this one is uniform but negative value. Bila negative value maksudnya apa? Okay, car itu sedang bergerak dengan apa? Okay, dia tengah decelerate. Dia punya velocity dia telah berkurang. Look at here, from 6 dia berkurang jadi 4, 2 and then 0. Dia tengah decelerate uniformly. A is uniform, okay? And the car still move in positive direction. Okay, awak tengok ya. Dari sini saya tunjuk. From 0 second, 1, 2, 3, 4. Okay, so from 0 to 1 second, so the car is moving, V is increasing, okay, A is uniform. But from 1 to 3 second, okay, dia buat apa from 1 to 3 second? Dia bergerak ke tidak? Dia bergerak, dia bukan tidak bergerak. Jangan confuse dengan graph X against T. Ini graph V against T. From 1 to 3 second, kereta itu masih bergerak with speed of 6. Okay, 6 meter per second. So dia pun bergerak lagi. Okay, this one V is equal to 6 meter per second constantly. Okay, and from 3 to 4 second, dia masih bergerak tetapi sekarang dia bergerak slowing down. Okay, in this position now, the car is slowing down until 0. Okay, nampak sini sampai 4 second dia slowing down until 0 meter per second. And then what happened from 4 to 5 second? What happened? From 4 to 5 second, the car is still moving but opposite direction. Okay, awak tengok ya. So let's say saya letak sini 2, 4, alamak ini saya letaklah graf ni 5.8. Okay, contoh 5.8 negative. So negative means that opposite direction. So daripada sini tadi saya guna color lain iaitu color purple. Okay, so from 4 to 5 second, okay, dia dah sampai sini, so dia patah balik. Okay, daripada sini dia akan patah balik. Alamak, ini saya tak buat, ini saya buat masa. Okay, ini kita kena kira dia punya distance lah. Okay, saya buatlah pula. Okay, so from 4 to 5 second, yang ni dia patah balik. Okay, dia patah balik, is moving in opposite direction. Okay, but what happened to the velocity? The velocity tadi kosong, kat sini kosong. Okay, here is zero velocity. And what happened? Okay, the velocity is increasing from 0 to 5.8 meter per second. From 0 to 5.8 meter per second. Okay, the velocity is increasing, but the car is moving in opposite direction. Okay, all right. So now look at the total distance. What is the difference between total distance and displacement? Okay, nanti bila you dapat nota ni, you boleh tengok satu-satu lah. Okay, dekat sini pun ada forward direction, which is positive direction, and then this is opposite direction. Okay, jadi area yang bawah ni dia adalah opposite direction, maknanya dia patah balik. Okay, alright, so total distance. Okay, so total distance, apa beza dengan displacement? Calculate the total distance, calculate the total displacement. Okay, total distance, so area under the graph, so we have A and B here. Okay, so we have A and B. Alright, so for the total distance, so it's travel from A to B. It's a total of A and B. Okay, maknanya awak kira area under the graph of A, and then you must calculate the area under the graph of B. Lepas tu bila you totalkan, tengok sini, area under the graph of A, okay, plus B. Okay, no direction because it's a distance. Okay, sebab kalau you kira area under the graph B ini, you akan dapat nilai negatif. Kenapa you dapat nilai negatif? Sebab dia bergerak in opposite direction, dia patah balik. Okay, that's why when you want to calculate the total distance, you mesti ignore the negative sign. But for the displacement, bila you kira displacement, okay, ini jangan tinggal negatif. Okay, area under the graph A, you akan dapat positive value. The area of B under the graph, part B you akan dapat negatif. Okay. Macam tu. Okay, sekejap saya check dulu. Kenapa saya punya ni? Sekejap Kenapa saya punya ni dia tak update? Okay, Hanif katanya uniform dengan constant sama ke? Samalah. Okay. Okay. So now next. Okay, yang ni mesti tahu beza antara distance dengan displacement. Jangan salah jawab. Okay. Okay, ini graph. Okay, kita ada 3 graph yang you mesti tahu. Saya kecilkan sikit. Alright. So now we have x against t. Okay. So look at here. This is the curve graph. X against t. Okay. Distance against time. Okay. So tengok kat sini So ini curve graph. Okay, kalau you tengok dekat curve graph, kalau kita ada curve graph macam ini, you nak tahu slope dia ataupun gradient dia increasing or decreasing. Okay, apa you boleh buat? Okay, cuba you lukis triangle dia. Okay, awak bayangkan sini. Awak naik bukit ini. That one is not the steepest one. Okay, dia masih landai. And bila kita lukis dekat sini, and this one, what happened to the gradient and what happened to the slope? The slope is increasing. Okay, dia punya gradient dia menaik. Lepas tu tanya diri awak, ini graph apa? X against t. So bila graph x against t, when the gradient is increasing, means that the velocity is increasing. Okay, so betul dekat sinilah, the velocity is increasing. Okay, so let's say we have a straight line graph here. Saya guna color lain. Okay, we have straight line graph here. Okay, bila straight line graph, maksud dia apa? Dia punya gradient is constant. M is constant. Okay, so bila M constant, maknanya velocity is constant. Velocity constant, bukan velocity is equal to 0. Okay, bila velocity is constant, when V is constant, A yang kosong. Okay, konsep kena betul. Alright, okay, good. Alright, so what happened to this one? Okay, you can see here. Semakin lama semakin melandai. Sampai sini landai. You can see here, M here is equal to 0. The gradient is equal to 0. Means that the velocity is 0. Okay. So now you can see that the gradient here is decreasing. So when the gradient is decreasing, means that the velocity is decreasing. Boleh? Okay. Ini awak boleh. Awak kena tahu, kena tengok. Kena tengok satu-satu. Kena faham. Okay, macam mana kita nak tukarkan graph xt to vt graph? Alright, so now let's say when you want to sketch the graph, firstly, look at to the timeline. So we have 0 to 5 second here. 0 to 4 4 kat sini, kita agak-agak lah sini 4. Okay, so from 0 to 4 second, okay, v is increasing. Kita dah tengok tadi kan, v is increasing here. Okay, so from 0 to 4 second, V is increasing. So betul tak V is increasing bila kita nak tukar? Yes, betul. Positive slope implies positive acceleration. Okay, you can tengok sini. So V is increasing here from 4 to 5 second. You can see here from 4 to 5 second. From 4 to 5 second, what happened? The V is constant. Betul tak V is constant? Okay, betul. Okay, ini. You kena tahu macam mana nak tukarkan. Okay, kalau kat sini tadi you dah kata dia constant, so dia mesti mendata lah dekat graph V against T. Boleh? Okay, so you must know that. Okay, alright, so apa lagi? Apa lagi kita nak tengok? So for this one, samalah kita dah discuss tadi. Let's say we have graph V against T and look at the slope here. Okay, the slope here is negative. Kalau you kira, the slope is negative. So means that gradient of the VT graph is negative, means that the acceleration is negative. So acceleration dia akan negatif. Okay. Sekejap Okay. So now how to draw your graph of A against T graph? Okay, ingat bila you nak tukar graph you, nak lukis, make sure timeline you mesti betul. Kalau kat sini tadi kita namakan dia 4 second, ini kita main letak je 4 second, sini 5, sini 4. Okay, so from 0 to 4 second, kita baca balik from 0 to 4 second, so V is increasing. V is increasing. What happened to the gradient? Okay, so the gradient is constant. So when the gradient is constant, means that A is constant. Bukan kosong, A is constant. Nampak tak dekat sini? A is constant. Okay, V is increasing dekat positive direction ke negative direction? It's positive direction. So that's why the value here is positive 4 meter per second. Okay, so dalam masa dalam masa 4 second tadi, sini nampak tak velocity dia constant. Okay, and from 4 to, ini saya tak tahu berapa, kita teka je lah 7, contohnya kan. So from here 4 to 7, so 4 to 7, the gradient is the velocity is constant. From 4 to 7, the velocity is constant here. Green arrow tu saya gerakkan. Okay, so the acceleration is equal to 0. So dekat sini acceleration is equal to 0. Betul tak kita lukis? Yes, betul. Kat sini acceleration is equal to 0. Okay, sini. Okay, dan seterusnya. Okay, from 7 to 15 second pula. From 7 to 15 second, look at here, we have the gradient is constant. The gradient is constant means that acceleration is constant. But the value of the acceleration is negative value. Okay? So kalau kita tengok kat sini, the speed V, the velocity is decreasing daripada 10 tadi. 10 dia turun sampai kosong. Sebab itu A dia negatif, dia decelerate. Kalau suruh explain, macam mana motion daripada 7 to 15? Okay? The object still moving in positive direction, but the velocity is decreasing. Therefore, the object is undergoes deceleration. Okay, decelerate. Okay, sebab itu kat sini you nampak, you punya A negatif. Okay. Itu graf lah. Okay, saya tak discuss lah banyak-banyak kan. Tak habis nanti. Okay. Okay, ini adalah projectile motion. So, saya rasa you tahu what is the formula of the projectile motion. So, we have, but you must know the keyword. Okay. Initially at rest. Bila soalan sebut initially at rest, means that U is equal to 0. Okay. Decelerate or brake. So, we have negative. Mesti letak negative sign. Okay. Kalau dia kata finally stop, means that V is equal to 0. Boleh? Ini adalah linear motion. Okay, projectile kat bawah. Okay, kita pergi lagi kat bawah. Okay, this is projectile motion. Okay, under free fall. Projectile motion under free fall means that, okay, tak ada angle. Okay, no angle. Okay, so let's say this is the reference point. Okay, saya tengok sekejap. Okay, so let's say this is the reference point. Okay, contoh reference point ataupun kita boleh panggil sebagai release point. Release level pun boleh. Okay, okay, so tengoklah bola ni. Okay, so from here, first case, awak mesti tahulah konsep ni. So when we try to throw the ball upward, okay, thrown upward, downward. So this case is upward. Okay, bila dalam calculation, you punya V mesti nilai positif. Boleh? Kalau kita baling daripada sini lah, kita baling ke atas. Okay, so dia mesti positif. Okay, so bola tu pun sampai dekat sini. Alright. And what is the value of Sy? This is the height. Sy, the vertical displacement must be positive value. Sebab dia bergerak ke atas. Okay. And for this one, okay, kalau kita baling ke bawah, Okay, so let's say this is the SY. So the value of SY here must be negative. Okay, and VY, alamak, sekejap and VY, because in vertical direction, so VY also negative value. Okay, so positive, negative, janganlah salah. Rugi kalau you salah. Okay, so now look at to the key point. Bila soalan kata the ball is drop. Okay, drop. U is equal to 0. Mesti tahu bila drop U mesti equal to 0. Kalau dia kata throw with initial velocity of berapa, then you ada you punya U. Okay? And what is the velocity when reach maximum height? Saya rasa semua pelajar tahu. Okay, when reach maximum height, V is equal to 0. Tapi jangan hafal je. Okay, mesti tahu. Mesti buat soalan, mesti tahu macam mana nak apply. Okay? And okay, this one, when thrown downward, U is equal to negative. When thrown upward, okay, U is positive. Okay. Okay. Alright. Misconception here. Okay, betul? Ada yang kata bila dah hit the ground, V is equal to 0. No. Okay. When we want to calculate the final V, okay. Contoh kita baling bola ke atas and then dia jatuh ke bawah. Okay. Sini V is not equal to 0. So we need to calculate what is V. What is the velocity of the ball just before it touch the ground. So dekat sini berapa dia punya V dia. So it must be negative value. Boleh? Okay, good. Okay, itu kena tahu. Okay, this one, projectile motion at angle of UY and UX. Okay, so when we projected an object at angle of theta, okay, tengok soalan bagi angle dekat mana. Tolong jangan hafal. Bila UX saja cos, bila UY saja cos. Jangan hafal macam tu. Tengok soalan bagi angle dekat mana. Okay, so soalan bagi angle dekat sini. So now look at the angle. Alright, and then look at to the UX and UY, the position. Okay, siapa yang duduk sebelah angle? UX. Okay, so now UX is equal to U cos theta. Bila you resolve, okay, components mana yang duduk sebelah angle, itu adalah cos. Okay, and the direction is to the right, so it's positive. Okay, positive, negative, jangan lupa. Okay, so this one should be positive U sin theta. Okay, kalau dia launch macam ni, okay, saya bagi theta kat sini. Okay, so UX and UY, so UX is not cos. Okay, tengok pada dia punya angle here. Siapa yang dekat dengan angle ni? UY. Okay, so UY is equal to, the direction of UY is downward, so negative U cos theta. And this one is positive because it's to the right, so positive U sin theta. Boleh? So tengok soalan, tengok angle, jangan hafal. Jangan hafal UX cos, UY sin, tak nak macam tu, okay? Alright, so now look at here, sekejap okay, so ini equation saya rasa tak ada masalah, you boleh ingat. Okay. Alright. So keywords kat sini. So bila launch horizontally, UY automatically is equal to 0. In projectile motion, at any point, okay, at any point, Vx is always equal to Ux. Kenapa saya kata macam tu? Okay, contoh saya kata, okay, awak cuba tengok sini. Dekat point A dengan dekat point B. Berapa value Vxa? Okay, the Vxa here, the value here is actually equal to Ux at any point. Okay, same goes to this one. Vx ini adalah Vx. This one B kan, kita Vxb. Ini pun sama dengan Ux. Nilai dia sama. Sebab dia tidak dipengaruhi oleh gravitational acceleration kita. Okay? But what happened to Vy? Vy dia berbeza. You need to calculate Vy. Okay? At any point, Vy dia tak sama. Jangan you confuse. So here Vy A. So here is Vy B. Vy A tak sama dengan Vy B, tapi Vx A sama dengan Vx B. Okay? Itu konsep. Okay, ingat tak you jawab soalan UPS? Ramai yang confused bila kita tanya soalan konsep. Okay, so this one is Sx, is horizontal, displacement, and the equation is Uxt. Okay, so in order to calculate what is the displacement here, contoh you nak kira, what is the horizontal displacement daripada sini pada point C. Saya letakkan nama kat sini point C. Okay. Macam mana you nak kira? Ux, you dapat nilai, awak dapat Ux from U cos theta, but now T, what is the time taken? What is the time taken when the object is launched from the origin to point C? Kena cari T. Okay? Macam mana nak cari T? Okay? So kita pergi pada SY kita. Tengok sini. SY, tengok maklumat soalan bagi, mesti boleh pakai. Where Sy is equal to Uyt minus half Gt squared. Okay? Boleh? So kat sini bolehlah cari time. Uy, tengok soalan bagi tak Uy. Dia projected horizontally ke tidak? Okay? When the question state that the object is projected or launched horizontally, automatically Uy must be equal to 0. Okay? Boleh? Alright, good. Okay, chapter 3. Laju saya cakap Okay. Okay, awak pun tak ada soalan Okay. Alright, so chapter 3, momentum and impulse. Okay, you must know, okay, so all the formulas is given and you must know how to use the formula. Okay, so linear momentum. So P is the product of mass and velocity. Okay, ini semua awak dah tahu. Okay, impulse, momentum, okay. Okay, impulse momentum theorem. Okay, this one, impulse is equal to the change of momentum here. Alright, and impulse also equal to Ft. Okay, impulse is equal to the change of momentum. Impulse is also equal to Ft. And then, delta P is equal to Ft. Kita boleh tulis macam ni. Okay. Ini kena tahulah sebab nanti mesti kita nak guna. Depends pada soalan. Sebab tu you nak pandai, you kena buat soalan. You tak boleh hafal formula saja. Okay. Alright, so when we have a graph of force against time. Okay. Apa benda ni? Sekejap So the area under the graph is the value of impulse. So boleh kira. Okay. Okay, lagi. Okay, so nak exam ni, semua dah ada dalam kepala. Sepatutnya sekarang ni awak tengok ni awak semua okay. Mana yang you dah faham? Okay, rasanya awak semua dah bersedia kan? Okay, so principle of conservation of linear momentum. We have collision. Okay, where the momentum, the total momentum before is equal to total momentum after collision. Okay, so we can write here where MV, selalunya ada dua objek lah awak selalu tuliskan. MA, UA plus MB, UB is equal to, okay, let's say they are moving separately. So we have MA, VA plus MB, VB. Okay, so now the collision. How about the kinetic energy? Okay, total kinetic energy initial sama tak dengan total kinetic energy final? Patah balik. Okay, so kalau dia sama, dia adalah elastic collision. So ini. Kalau dia tak sama, dia apa? Dia adalah inelastic collision. Okay, bila kita jawab, jangan main jawab je. You mesti kira, you mesti tunjuk. What type of collision? So the total kinetic energy initial here is not the same as total kinetic energy final. Macam tu. So, kinetic energy is not conserved. Bila you jawab, you mesti tunjuk you punya proof. Okay, bukan jawab saja. Okay. Next. Ni formula ni awak kira lah kan. Half, apa formula kinetic energy? kalau kita ada dua objek kan. Okay, kita tulislah. Total kinetic energy initial ada dua objek. Half, ini initial, mass A, UA squared plus half mass B, UB squared. Okay, and kira pula ni kira berapa. And then you kira pula final. Half MA VA squared plus half MB VB squared. Berapa? Okay, sepatutnya you tengok. Sama tak dua ni? Kalau sama, dia adalah elastic. Kalau tak sama, dia adalah inelastic collision. Okay, so saya rasa ini semua orang dah tahu, kan? Okay, ini case 1. After collision, mereka bergerak berasingan, okay, moving in separate velocity, in their own velocity. So we have before momentum is total momentum, okay, is equal to the final momentum, okay. Initially, tengok U2 tak bergerak. So bila U2 tak bergerak, belakang dia ni hilang sebab kosong. Okay, jangan hafal sentiasa ada M1U1 plus M2U2. Kalau objek tu tak bergerak, dia mestilah kosong. So dia hilang, okay. So bila after collision, they moving separately. So means that mereka ada V mereka sendiri, V1 and V2. Okay. How about this one? A and B. So tak 1 dan 2 lah. Object 1 and object 2. Okay. They are moving together. Dia bergerak sekali. That's why we combine the mass. M1 plus M2 and V ini adalah final velocity. Inilah final velocity yang kita kira dekat sini. Tengok soalan, baca betul-betul. So sekarang U2 is not equal to 0. Okay. Untuk case yang kedua, mass pertama bergerak, mass kedua bergerak dan kedua-duanya ada initial momentum sendiri. So the total momentum 1 plus the total momentum is momentum 1 plus momentum 2. So tak boleh lah suka hati jadi kosong kan, U2. Okay, good. Okay, ini paling penting. Jangan lupa, ini selalu ramai salah. Okay, tengok dekat sini. Okay, U2 is moving in opposite direction to the left. So bila awak kira, selalunya majority akan tertinggal negative sign. Okay, so U1 is to the right is positive sign, but U2 is opposite direction, they collide. Okay, so U2 mesti negative. And what happened after collision? Okay, dia bergerak berasingan, moving in separate, not separate direction, still in one direction, but moving in their own velocity, V1 and V2. Okay, alright. Case keempat. So, kita tak tahu soalan macam mana dia nak tanya esok, case 1 ke, case 2 ke, case 3 ke, case 4, macam tu kan. Okay, so ini sama juga, U2 to the left. Okay, so we have V1 and V2. V1 is moving to the left, mesti letak negatif. V2 is to the right, kita letak positif. Kalau you tersalah letak, maknanya jawapan akhir you akan salah. Okay, konsep dekat situ, the direction of the motion. Okay, next. Okay, so 2D collision. 2D collision. Kita tak tahu esok dia nak tanya 1D collision ke 2D collision. Okay, so ini you dah prepare lah, you dah study kan. Awak pun dah pandai. Okay, so let's say we have U. Okay, so U here, look at here. U is moving in X component. Saya letak U, AX. Dia bergerak tak in Y component? Tidak. So it's U, AY is equal to 0. Boleh? Okay, so after collision, so we have angle here, which is here is 30 degree and here is 60 degree. Okay, so what happened? After collision, V, ini adalah VA, tapi you need to resolve into X and Y components. Okay, so you have, sekejap. So you have VAX equal to cos ke sin. Okay, VAX duduk sebelah angle, so adalah VA cos 30 degree. VY is upward, positive. VAY is VA sin 30 degree. Okay, same goes to B. Okay, B pun you kena resolve. Okay, in this direction B, VB. So we have VBY But remember, VBY tu mesti negative because the direction is downward direction. Okay, downward direction. So it's VBY, so dia adalah negative V sin 60. Ini adalah VB cos 60. Okay, so when we have 2D collision, kita ada X, kita ada Y. Okay, so kita ada X dan kita ada Y, kita kena buat kedua-duanya. Okay, kita kena selesaikan kedua-duanya. Okay, total Fx and total Fy. Berapa start ni? Sekejap Okay ke tu? Sekejap saya takut internet saya problem. Okay. So saya kena check sebab saya seorang-seorang je ni, so saya tak sure saya dah terkeluar ke. Okay. So now when we have 2D collision, kita buat satu-satu. Okay. So kita kena ada, okay, contoh saya buat. Total, saya nak buat X dulu. Contoh So X, saya mesti tulis total momentum initial X equal to total momentum initial, final X. Ini tengah cerita pasal X, so mesti ada tulis X. Okay. So kita ada X here and X here. Okay. So now, MA, so kita pun tengoklah UA bergerak tak in X component? Yes, dia bergerak. Sekejap UA X plus MA. MA UA X plus MB UBX. Tulis semua, tak ada masalah. Plus MA VAX plus MB VBX. Okay, sebab boleh jawab, tulis satu-satu. Okay, jangan keliru. Okay, so now tengok pada case 1 tadi, B kita ini tidak bergerak. So dia tak ada. Okay, UB initial tak ada. Okay, so UB initial dengan final. UB ini, yang ni bergerak tak? Alamak. Yang ni dia tak beritahu MA UA VB. Okay, kita consider tidak bergerak lah. Okay, so dia akan jadi kosong. So ini akan jadi kosong. Okay, so kena tengok pada soalan. So kosong. So kita pun tulis MA UAX equal to MA. So VAX kita tadi apa dia? Dia adalah VA cos 30 plus, okay, MB VBX kita adalah, ingat balik VBX kita positif ke negatif? So kita check balik, dia adalah positif. So dia positif lah. VB cos 60. Boleh? So dapatlah ini. Ini yang untuk X. Ini yang untuk X saja. Okay. So you boleh masukkan nilai lah ikut pada soalan yang diberi. Tapi untuk Y, okay, kalau you tengok untuk Y, kat sini kosong. Kenapa kosong? Sebab A tidak bergerak in Y component. Before collision, A is not moving in Y component. And B pula at rest. Okay, it's not moving. Okay. Suara saya putus-putus. Sekarang putus-putus lagi ke? Okay, ada yang kata suara main putus-putus. Sekejap Suara saya tersekat Dah okey ke sekarang? Okey tak sekarang? Tak. Okey, sekejap. Ada yang kata okey. Sekarang dah tak. Okey, good. Okey. Nasib baik dah tak. Okey. Okey, kita sambung. Okey. So ini case yang kedua. Okay, kalau you tengok beza case pertama dengan case kedua, case pertama tadi only X is moving in in case pertama tadi only A is moving in X direction. Dia moving to the right. B at rest. Okay. For the second case, tengok. Okay, soalan bagi. Okay, for the second case, kita ada 1 and 2. Okay, so object 1 is initially is moving at angle of 30 degree. Contoh kan. Okay, sini. And mass 2 is moving at angle of this one. Okay, and what happened to the collision? Dia terbalik. After collision, 1 and 2 combine together and then they are moving together. So kita ada V. So this one is V final. Okay, so momentum P final dia, P final in X component must be M1 plus M2 V. Sebab dia bergerak sekali together. But for the initial momentum, untuk objek pertama dan objek kedua, you must resolve. Okay, look at here. Okay, so you need to resolve into, so this is V initial 1. Sorry, saya letak U lah. U1. So you need to resolve. Okay, hati-hati bila resolve, tengok pada angle yang diberi. So here is 30 degree, but angle here not 30 degree. Situ berapa? 60. Okay, ini yang selalu, kalau awak rasa masih confused, tolong check betul-betul. Bila jawab, check. Hati-hati, jangan careless. So kalau sini 30 degree, angle here also 30 degree. Okay. So, resolve lah. Sekarang U kita ada X and Y component. Di mana U1X equal to U cos 30 and U1Y is equal to negative sebab dia downward kan. U sin 30. Okay, boleh. So kena resolve. So in X component, look at here. Okay, untuk M2 pula, M2 pun sama. You need to resolve into X and Y component. Okay, so we have U2. So you ada U2X and U2Y. Okay, so U2X is equal to, awak yang ni kita tak ada nilai angle dia. Okay, saya letak saja theta. So U2X is equal to U2 cos theta and U2Y is equal to U2, apa tu U pula ni? U2 sin theta. Okay. So now when we try to write the equation in X component. Okay. Tengok ya. Yang ni kita ada M1. This one is U1X. Okay. Plus this is M2 and this is V2X. Okay. Ikut komponen mana yang you tengah buat, X ke Y. Equal to, after collision, kedua-duanya bergerak in X direction to the right. Okay. So, M1 plus M2 V. Okay. Sebab itu penting you tulis formula satu-satu. Kalau you skip, you akan masuk nilai tu nanti salah, terbalik, negatif tertinggal. Okay. So, tak nak macam tu. Okay. Yang ni pula. Okay, the last case. Initially kita ada mass 1 kita ada U1X, tapi mass 2 tak ada U1X, U2X. So U2X dia kosong. Sebab dia tidak bergerak in X component. Okay, this one U1Y is 0. Because it's not moving in Y component, it's moving to the right. And this one U2Y ada nilai. Okay, and what happened after collision? 1 and 2. So we have M1 plus M2. So combine. Okay, kalau you buat X component, so sini kena VX. Okay. Kalau you tengah buat yang Y component punya, dia akan jadi M1 plus M2 Vy. So mesti ada Vx and mesti ada Vy. Boleh? So that's why here you need to resolve into X and Y component. V final mesti ada X, mesti ada Y. Okay? Itu adalah 2D collision. Boleh? Alright, good. Okay. Saya terus gerak. Tadi saya ada nampak soalan. Tadi line saya tak okey. Saya proceed Kalau ada soalan nanti yang pelajar saya, you boleh PM tepi. Terlambat. Okay. Okay, free body diagram. Oops. Okay, so free body diagram. Berapa ramai yang masih tak tahu lukis free body diagram? Okay, awak tak patut tak tahu sebab esok dah nak exam. Okay, okay. So you must know the type of the forces. So weight, so force exert on a body. So semua orang pun dah tahu. Okay, so when we have the inclined plane, okay, so make sure you resolve. Okay, W ni you tarik straight ke bawah. W. Okay, bukan W. Okay, the direction of W bukan macam ini. Okay, the direction of W bukan perpendicular to the surface. Ini surface. Surface of motion dia. Okay, so W must be perpendicular to the base. Ini base dia. Okay, so yang hijau tu salah, kita padam balik. Jangan buat macam ni. Okay, tengok sini So ini base dia 90 degree to the base. Wait, jangan sengit. Okay, and then okay, you must have your normal. Okay, normal. Okay, and weight angle kat sini mesti sama dekat sini. Saya pasti awak semua dah tahu. Okay, bila weight ada angle, you must resolve your angle into X and Y component. Okay, so you have WX and WY. Okay, so WX is equal to mg sin theta. Okay, and this is mg cos theta. So the direction is downward, it's negative value. Boleh? Alright, good. Okay, so now when you have the inclined plane, okay, saya nak sentuh sikit. Bila you ada inclined plane, alah buruknya saya punya. Sekejap saya. Jadi tak? Okay, good. Okay, so when you have inclined plane here, okay, make sure you take the surface. This is the X component. And this is the y-axis, x-axis and y-axis. Okay, so when you draw your free body diagram, okay, x and y. Awak tengok balik awak punya free body diagram here, sketch dulu pada soalan. Normal is in y component. Okay, normal is in y component. Y, x. X-axis must be the surface of the motion. Okay, kalau dia flat surface, so this is the x-axis and this is the y-axis. Flat surface tak ada masalah. Okay, betul? Okay, so for this one, bila kita draw the free body diagram, so and lepas tu kita ada apa? WY, okay, W kat sini. So angle. Alright, so if this is the rough surface, so you must have the friction. Okay, friction kat mana? Lukis dulu A kecil, contoh dia bergerak ke bawah kan, dia turun ke bawah macam ni, dia sliding down. Okay, sliding down the plane. Okay, so the frictional force must be opposite direction. Macam tu. Okay, dah betul lah. Okay, ni dah complete dah you punya free body diagram. Mesti ada arrow and then all the arrows, you must label all the arrows. Okay, and also the X and Y component. X and Y axis. Okay, and now when you want to proceed to your calculation, make sure you tulislah nilai dia. Kita nak resolve WX and WY. So WX berapa? WY berapa? WX to the left or to the right? Okay, kena ingat. Okay, so WX and friction, siapa yang positif? Okay, that's why it's very important, okay, you must know the direction of the motion. Objek itu bergerak ke mana? Okay, so now the object is moving to the right, means that WX must be positive. WX minus friction. Okay, total Fx equal to MA, so dia akan jadi WX plus negative friction. So dia akan jadilah WX minus friction equal to MA. Boleh? Okay, good. Okay, so the next case we have the hanging object. Okay, kalau macam ni kita ada weight ke bawah lah, tension ke atas. Arrow mesti always outward from the object. Yang ni pun sama lah, kita ada weight ke bawah. Okay, and this is also weight ke bawah. Okay, so when the frictionless pulley, so means that tension TA is equal to TB. Okay. Okay. Ni boleh lah nanti saya ni gerak-gerak. Okay. Okay, so look at the keyword. Keyword dalam soalan selalunya dia akan sebut constant V. Okay, so bila constant V, tengoklah kalau dia kata it's moving to the right with constant V. Kan? Bila constant V dia akan jadi move to the right means that horizontal direction or components. Okay, Hani Nur Aina tanya madam macam nak tahu sudut dia terletak kat mana. Which sudut? Nur Aina. Ada dua Nur Aina. Nur Aina Atinin. Sudut yang mana? Yang incline plane ke? Hani Nur Aina. Saya bincang PST. Okay, PST dengan PDT sama. Cumanya PST contoh macam chapter 3 tadi. PDT tak ada 2D collision. Okay? Boleh? Tapi PST dia ada. Sebab tu kalau you PDT, you tak belajar 2D collision. Okay, you belajar 1D collision only. Okay? Nur Aina Atinin. Okay, kalau you baca macam mana nak tahu sudut dia terletak kat mana? Which sudut Aina? Okay? Alright. So now, when it's moving to the right with constant velocity, yang ini kena tulis betul dulu. Fx total X equal to MA. Dia bergerak dekat mana? X component. Okay, tapi bila soalan sebut constant V, means that the acceleration here is equal to 0. Boleh? So, bila awak tulis, contoh tadi mana? Tadi kan WX minus friction equal to MA. Kosong lah sini. So dia akan jadi mg cos, sin. mg sin theta is equal to friction. Formula friction apa dia? mg sin theta is equal to mu kn. Soalan suruh cari mu contohnya kan. So mu k is equal to mg sin theta over n. Alamak, tak boleh selesaikan sebab tak ada normal. Okay. So, tanya diri awak, normal dekat mana? In what direction? In what components? Dia punya free body, dia punya arrow dalam free body diagram. Okay, so normal kita boleh dapat daripada total Fy. Okay. Kalau tadi objek tu bergerak in X component with constant V, tak mungkin dia bergerak in Y. So dia tidak bergerak in Y component ataupun in Y direction. So y automatically is equal to 0. So it's equal to 0. Boleh? Okay, good. Okay, so y tadi mana y? Kita tengoklah contoh kita tadi ni. Dekat mana? Contoh macam tadi kan. So n minus lah. N plus wy. Wy is equal to 0. Saya ambil yang incline plane yang simple tadi. Okay. So kita, so dia akan jadi n plus negative wy. Because wy, the direction is downward. Okay, is equal to 0. So n is equal to wy, where wy is equal to mg cos theta. Boleh? So dapatlah n. Kira n, dah dapat n, barulah masukkan dekat sini. Okay? Macam tu. Bila tak ada n, tengok pula yang y component. Okay, tengok sekejap soalan. Madam, kalau yang incline tu bergerak ke kiri, maksudnya wx dia F tolak wx No, Hanif Husaini. Okay. Incline plane. Okay, saya jawab soalan Nur Aina dulu Nur Aina tanya macam nak tahu angle dia. Okay. Macam ni Nur Aina dan yang lain. Macam ni kan? Okay. So awak nak tahu angle dia yang mana? So this is the angle theta, and then we have object here. Okay. So tengok sini weight downward. Kan straightly downward tu. Saya tukar color. Apa nak tukar? Okay. So this one is perpendicular to the surface y, and then we have perpendicular to the x surface. Okay. So kalau sini, kita tengok triangle yang saya colourkan dengan colour kuning ni. Okay, this one. Okay. So kalau sini angle theta, sini 90 degree kan? Apa ni? Kenapa hilang? Okay. So sini akan jadi 90 degree. Betul tak? Theta 90 degree. Contohlah kita tak nombor kan, tak nampak pula. So theta ni adalah 30 degree. So here is 60. Okay. So kalau here is 60 degree. Okay. Yang dekat sini pun berapa? Sekejap macam mana saya tunjuk 60 degree. Yang ini adalah, sekejap So ini adalah 4 Yang ini adalah 60 degree. Dia ada triangle ni. Ini adalah 60 degree. Ini theta ini. Maaf saya guna tablet. So ini adalah 60 degree. So sini pun mesti 60 degree juga. Nampak tak yang saya colourkan dengan warna merah ni? This one is 60 degree. Okay. So yang colour hijau tu akan jadi, this one should be 30 degree. Okay. So if the question give you the angle of the inclined plane here, ni inclined plane here, angle here is equal to this one. Rapat ke sini, 30 degree. Bukan yang dekat belah yang merah tu. Boleh? Boleh? So ini kan parallel ni. Ini kan surface ni kan parallel ni dengan ini. So kalau kat sini 60 degree, saya guna color merah. Awak confused. Okay, kalau kat sini 60 degree, so sini pun mesti 60 degree lah. Okay, parallel. Yang ni parallel to the surface. So 60, yang ni should be 30. Okay, boleh? Madam kalau incline plane tu, okay, Hanif, bergerak ke kiri maksudnya WX dia F tolak WX. Okay, macam ni Hanif. Okay, saya bagi yang ni Okay, kalau dia bergerak ke kiri A, okay, contoh awak tolak dia. Okay, awak tolak ke macam ni. Awak tolak ke belakang kan. Dia bergerak ke kiri. Lepas tu kita ada frictional force ke kanan. Okay. Tak bolehlah awak kata F yang positif. Sebab F ke kanan. Bukan. Okay. Awak nampak tak saya punya A ni? A saya ni ke kanan kan? Okay. Force mana yang same direction with A? Frictional or F? mestilah F. Even though the motion is to the left, doesn't mean you tulis F minus F. Salah. Okay. Kalau you nak tulis macam ni boleh, tapi you kena buat F minus F equal to negative MA. Yang ini you kena letak negatif because the motion is to the left. Okay. Tapi saya selalu nak ingatkan awak, lebih mudah awak tengok the direction of the acceleration is to the left and the direction of F also to the left. Mereka sama kan? Yang sama tu adalah positif. So dia akan jadi total Fx equal to MA. Okay, sebab saya tak suka ada negatif macam ini. Okay, so saya akan ambil same direction. So F must be positive. So dia akan jadi F plus negative frictional force is equal to MA. F minus F equal to MA. Boleh? Chapter 4 ni kalau boleh semua orang kena jawab betul. Okay? Okay, good. Okay, let's tengok sikit. Alright, Ikhwan. Okay, saya random je Okay, next. Chapter 5. Okay, so chapter 5. So work done by constant force. So formula, okay. W is equal to Fs cos theta. Okay, kita ada. Okay, ini semua awak dah tahu lah ni. Dia tahu. Okay, tak apa. Okay, so work done. Okay, we have first graph of F against S. Okay, so the area under the graph is the work. Okay, you boleh kira lah. So make sure bila you kira, bila jawab soalan work, tolong bagi jawapan dalam joule. Janganlah bagi jawapan yang macam ni. Kan? Okay. Seeloknya, secantiknya joule. Okay. Macam power. Apa power? Jawapan power. Apa dia punya unit? Watt. Okay. So, kita kena ikut ini. Sebab kita tak tahu pada tahun itu, ketua pemeriksa kita terima ke tidak. Macam itu. Okay. So, yang paling betul, kita refer kepada power. Power, what is the unit of power? Mestilah watt. Okay, jangan you derive and panggil panjang-panjang. Unit mesti ingat, okay? Kalau tak, hilang satu markah. Okay, so energy and conservation of energy. Okay, bila masa kita ada gravitational potential energy, okay, when the position of the body is at this certain height. Okay, contoh, inilah the height of a body from the initial position. Okay, contoh you dekat sini kan. Ini awak ni. Okay, this is you on the top of the building. Okay, you want to jump from the top of the building. Okay, so what type of energy yang you ada? Kinetic energy tak ada sebab you tidak bergerak. Okay, elastic potential energy pun tak ada because you are not spring, you bukan compress or expand. Okay, so you have your potential energy. Okay, so elastic potential energy, bila masa kita ada elastic potential energy? Bila soalan tu melibatkan spring. When the spring compress or extend. Okay, by an amount of X. X tu compression lah, the amount of compression or expansion ataupun extension. Okay, ada spring compress, mesti energy yang terlibat ada elastic potential energy. Okay, kinetic energy, energy bergerak mesti ada kinetic energy. Energy tidak bergerak, dia mesti kosong. Okay, kalau tak bergerak tak adalah V. V ni akan jadi kosong. Okay, conservation of energy, okay, ini kena tahu. Okay, work energy theorem. Okay, the change of kinetic energy, K final minus K initial. Okay, dan satu lagi, okay, kalau when involve the change of height, so we can calculate the work. The work done is equal to U final minus U initial. Maknanya MGH final minus MGH initial. Kalau dia kereta saja, apa ni? Kalau dia kereta saja bergerak dia tak ada perubahan height, no change in height. So the car is moving to the right with, let's say the initial speed is 2 meter per second squared and V is equal to 5 meter per second squared. Okay, so you want to calculate what is the work done. So W is equal to the change of the kinetic energy, half mv squared final minus half mv squared initial. Okay, ini delta. Dia terbalik. K equal to delta U. Okay, boleh? Okay. Alright, the average power. Okay. The average power is the average work done per unit time or the rate of work done, delta W over delta T. Remember delta W, when we have the change of the kinetic energy, we can have K final minus K initial. Okay, boleh guna. Ataupun we have the change in the potential energy. Okay, and for the instantaneous power, we want to calculate the instantaneous power. For example, okay, so we have the object is moving in this direction, V is equal to 10 meter per second, and then we have F in this direction, iaitu 2 Newton. Alah kecilnya angle. Okay, so what is the instantaneous power? Okay, so it's equal to FV cos theta. Okay, you boleh ambil theta ini, angle, is the angle between F and V. Alright, so that one is the instantaneous power. And for the average power, what is the average power? You need to know what is the final. What is the final velocity? Okay, contohlah objek ni bergerak sampai sini. Kat sini dia ada U dia tadi bergerak and then dia ada V. Okay, so you want to calculate what is the average power. Kiralah delta K over what is the time taken to move from here, from the starting point to the ending point yang kita nak kira tu. Okay, so it's equal to delta T. Boleh? Chapter 5, awak kena buat soalan. Okay, ini yang penting lah. Okay, kena tahu the type of energy dekat position mana. That's why, okay, kalau yang tak melibatkan spring, kalau you tengok saya punya contoh soalan dalam set 4. Soalan dalam set 4 dekat channel saya ada letak satu soalan yang berkaitan dengan the change of height and also involve the compression of the spring. You boleh tengok dekat situ. Okay. Kalau contoh ini soalan yang you biasa nampak sebelum ni. Contoh Okay. So A and B. Okay. So dekat A you ada energy apa dekat A? Okay. Kalau start from rest, okay, maknanya you ada U saja, UA. Lepas tu dia pun bergerak, it's moving and reach point B, and at point B we still have the height of B, and at point B we have UB plus the kinetic energy. Kinetic energy dekat B. Okay? Tak adalah elastic potential energy. Jangan tiba-tiba awak tulis UB and then awak masukkan half kx squared. Okay? Tengok betul-betul. Okay? Keadaan itu. Alright. Okay, let's move to chapter 6. Okay, circular motion. Okay, this is very important. Mana? Omega. Okay, omega. Ada yang tak tahu? Baca balik soalan. Kalau soalan bagi omega is equal to 2 revolution per minute. 2 revolution per minute bukan 2 radian per second. Jangan terus ambil nilai 2 and then you straightly substitute in the equation. No. Okay. So you need to change 2 revolution per minute to radian per second. Baca soalan betul-betul. Okay. So 2 revolution. So omega is equal to 2 revolution per minute. Saya suka buat darab silang supaya awak nampak. So 1 revolution, satu pusingan ni. Satu pusingan ni berapa? It's 2 pi. 2 pi radian. Okay. So 1 revolution 2 pi radian, cancel. Kalau omega you salah kira, salah lah. Okay, ini basic you kena tukar dulu. Okay. And 1 minute is equal to 60 second. Minit dekat bawah, partner dia mesti duduk dekat atas. Okay. And then omega is equal to 2 times 2 pi radian over 60 second. Okay, boleh? Okay. So tukarkan dulu ke dalam radian per second. Alright. Okay. Kadang-kadang soalan tak bagi omega. Soalan bagi you frequency. So frequency is equal to 2 Hertz. So you need to know what is the omega. So omega is equal to 2 pi f. Ini you mesti tahu. Okay. Okay, good. And also this one, the formula. Saya rasa formula you tak ada masalah. Okay. And finally, the relationship between omega and the period. The period is the time taken to complete 1 revolution. Masa diambil untuk melengkapkan satu putaran. Kalau 2 revolution per second, maknanya dalam 1 saat, dia berpusing 2 pusingan. Okay? 2 revolution per second. Okay. So sekarang, the relationship omega is equal to 2 pi over t. Okay? So kalau soalan bagi you t, you boleh cari omega. Okay? So inilah yang tadi kita buat. 35 revolution per minute. Apa? 35 revolution per hour. Okay? 35 revolution per second. Okay? So you kena tukar RPM. Okay. Okay, ini saya tak nak sentuh. Saya nak sentuh yang ini. Okay. So esok kita tak tahu soalan mana yang keluar. Pendulum ke, kan? Ataupun Ferris wheel. So in the scalar motion, we have a horizontal plane and also vertical plane. Horizontal plane and vertical plane. So this one is horizontal. Okay, horizontal. Okay. So, bila kita cerita pasal horizontal, okay, saya zoom sikit. So, the free body diagram, the wake, and also T. Okay. Bila saya lukis free body diagram, okay, I like to draw the direction of the centripetal acceleration. Kalau dia linear motion, I like to draw the direction of the A acceleration. Okay. So means that the acceleration is in this direction. Okay, AC. So ini free body diagram saya. So saya akan lukis kecil dekat atas. Okay. So now I know that this value is positive. T sin theta because the direction is the same direction as the centripetal acceleration. Okay. So now the object is moving in a circular motion. Okay. So total Fx is equal to MAC. Sebab dia centripetal, sebab dia centripetal, sebab dia adalah circular motion. So dia adalah centripetal acceleration. Sorry, saya terdistract pula sebab dah nak pukul 4 kan. Okay, saya tak sempat nak habiskan. Okay, it's okay. Okay, so now look at your free body diagram. Ada force apa dalam X component? You just have T sin theta. You just resolve your tension. Okay, the tension of the string. Okay, so T sin theta is equal to, okay, kalau soalan suruh cari centripetal acceleration. Kalau soalan suruh cari centripetal acceleration, tak payahlah you tukar mv squared over r. Okay, stickkanlah saja. So AC equal to T sin theta over M. Okay. But if your questions ask you to find V ataupun dia bagi nilai V dalam soalan, so you need to change lah. This is AC, where AC is equal to V squared over R. Okay, so soalan bagi V, masukkanlah V. Okay, Kalau soalan tak bagi V, dia bagi AC, you boleh masukkan. Boleh. So now in Y components, so we have two forces, Ty and this is Ty and W. Okay? So total Fy is equal to 0 sebab the object is moving in horizontal plane. Okay, horizontal plane means that kita hanya ada macam ni tadi kan, AC, so kita hanya ada total Fx equal to MAC. Dia tidak bergerak atas dan bawah. Okay, it's not vertical motion. It's not vertical circular motion. Okay, so ini akan jadi kosong. Okay, boleh. Alright. Ini pun samalah. Okay, lukis dulu free body diagram sebab tu free body diagram penting. Okay, so AC. Okay, kenapa direction centripetal acceleration saya ke kiri bukan ke kanan? Okay, sebab this is the center of the circle. Okay, the direction of the centripetal acceleration must be always towards to the center. Okay, so now that's why total Fx is equal to MAC. Okay, and it's equal to mv squared over r. So y kosong lah sebab dia tidak bergerak in y component. Boleh tak kalau incline plane punya FBD kita buat sengit ikut gambar? Sengit ikut, oh incline plane. Maksudnya awak nak sengit pusing lah. Okay. Bila you dapat soalan draw the free body diagram, okay, kalau boleh seeloknya, okay, seeloknya you buatlah X and Y component. Okay, tegak, you pusingkan. Tapi kalau you rasa blur, tiba-tiba you tak boleh nak ni, okay, you still nak buat contoh incline plane tadi, saya patah balik sebab ada yang tanya. Okay. As long as direction you betul, kira betul. Macam ni. X. Ini Y. Sini Y, sini X. Okay. So, turun. So, W. Okay. So, saya rasa Nur Syifa Nabila tanya boleh tak kalau dia punya tu sengit. Okay, maknanya dia nak buat sengit macam ni. Y. X. Itu maksud dia. Okay. As long as you label betul, this is Y and this is X, tak ada masalah. Menjadi masalah bila you tak label. Okay. Sorry, saya tak tunjuk. Okay, sorry, saya ulang balik. Okay. So this is the incline plane. Okay. Maksud Nur Syifa tadi mungkin dia nak sengit juga macam ni. Dia tak nak tegakkan dia punya Y dengan X. Okay. So make sure you label Y dengan X. Okay. So now normal force mesti dekat sini. Tak bolehlah tiba-tiba normal force yang macam ni. Confirm dah salah. Okay. And then WY is straightly downward. Itu pun cik saya ingat kan. Omega. Theta. Okay. Boleh? Kalau ada friction, rough surface, ni saya buat sengit tak ada masalah. As long as semua arrow ada label yang betul, arrow you betul. Okay, jangan tiba-tiba arrow awak macam ni pula. Ya tengok saya tunjuk Tiba-tiba yang line ni dah betul, tiba-tiba arrow macam ni. Salah. Free body diagram tak dapat markah yang tu, salah. Okay. So friction, kalau objek tu bergerak ke bawah macam ni, A. Okay, alarm dah berbunyi. Okay, so friction mesti opposite direction. Saya ambil colour merah. Tak nak lah merah. Colour hijau. Okay, so friction kat sini. Okay, kalau dia sliding down, friction dia mesti opposite direction, right? So mestilah ke sini friction dia. Okay, tak ada masalah, betul. Okay, still dapat markah penuh. Okay. Sebab you label semua. Y, X, kita tahu ini adalah you punya surface tadi. Okay. Next. Okay, let's say soalan esok dia bagi apa ni? Ferris wheel. Okay, so Ferris wheel, ni awak yang tengah duduk, this is you. Okay. And this is also your friend. This is you and this is your friend. Your friend kita letak color purple. Kan? Okay, so let's draw the free body diagram. Okay, so this is your friend. Your friend, not your girlfriend. Okay. Ini adalah you. Okay. You duduk bawah, your friend duduk atas. So the free body diagram, weight always downward. Normal must be normal antara awak dengan surface of the seat. Kan? Normal mesti perpendicular to the surface. Okay. Ada je surface, ada je contact object dengan surface, there is a normal force opposite direction pula. There is a normal force that is perpendicular to the surface. Okay. So N. Boleh? Okay. Dan ini yang saya suka lukis. Centripetal acceleration. Okay, kalau you ikut apa yang semua cikgu-cikgu dan pensyarah yang ajar, you takkan salah. Tapi kadang-kadang you tak nak ikut. Kan, you tak nak tulis. You nak skip. Tak boleh lah main skip-skip. Okay. Awak suka tak kalau pensyarah ajar skip-skip? Tak suka kan? So jawab tu kena jawab betul-betul. Okay. Okay, so now this is vertical circular motion. The centripetal acceleration is in this direction. Okay. So we must write total Fy equal to MAC. Bukan total Fx, total Fy. So, okay, at the top of the Ferris wheel, kawan awak tadi, dia adalah, tengok sini, okay, work pula. W is the weight, okay, tengok sini, weight is the same direction with the centripetal acceleration. So dia adalah W minus N. W ni yang positif, bukan N minus W. Okay, but for this one, ambil color lain sekejap. Okay, N here, dia adalah N minus W equal to MAC. Boleh? Saya tulis kat sini. N minus W equal to MAC. Ini yang you kena betul. Okay? Kalau itu you tersilap, saya tak boleh nak tolong. Okay? Alright. So, ini betul. Okay? Okay, ini konsepnya lah. Soalannya saya tak tahulah sebab sini tak ada soalan. Okay, ataupun you naik roller coaster. Okay? Ini awak ke atas, kepala awak dah ke bawah. Okay. Ini kawan awak. Okay. So, lukislah. Okay. Weight is downward. Oh my god. Sorry. Okay. Hai, kenapa awak tak boleh tulis? So, W. Okay. So, normal is upward at the bottom. Okay. So, A direction upward. So, W minus T or T minus W. Mestilah T minus W equal to MAC. Total Fy is equal to MAC. Okay. And this one, we have weight downward and we also have normal. Okay. Okay, normal. So, dia adalah yang ni objek alamak, ini tak apa. Ini dia guna T pula. Okay, kalau T, let's say you ada batu, a rock that tied to a string and it's moving in a vertical circular motion. Okay. Alright, so ini you ada tension lah, T. T and weight. Yang ini tadi saya cerita pasal roller coaster. Okay, you ada normal force and also the weight. Okay, so dia akan jadi kat bawah pula. So weight and the tension, ni tali ni awak ikat kat tali. Okay, so T. So at the bottom, it should be T minus W equal to MAC. Centripetal acceleration must be always toward to the center. So now T plus W is equal to MAC. Okay, boleh. Ini. Top bottom mana? Bottom dah hilang. Ada top je. Okay, this one is for the top. So for the bottom, this one lah saya dah tuliskan. Okay, so at the top, the equation of the object is W plus T equal to mv squared over R. Okay, at the bottom, ini dalam nota ni kehilangan pula. Okay, so T minus W equal to MAC. Okay, so ini adalah roller coaster. So at the top we have AC W plus N equal to MAC. Here we have N minus W equal to MAC. Okay, this one. Boleh? Okay. Equation tu jangan tersilap. Tambah ke tolak? Atas ke bawah? Okay. Okay. 6. 7. Okay. Ini chapter yang paling senang. Gravitation. Okay. So, this one we call as point mass. Mungkin ada yang still keliru point mass tu apa? Test mass tu apa? Ini adalah test mass. Test mass is the object ataupun a body yang mengelilingi. Dia yang bergerak. Okay. Kalau point mass yang static. Okay. So let's say this is the earth. Okay. And the point mass is ME. The mass of the earth is the point mass. Okay. Kalau sini adalah, for example, this is your satellite. Okay. The satellite is orbiting the earth. Siapa yang bergerak? Satellite kan? So dia adalah the test mass. Boleh? Okay. Okay. So sekarang, kalau soalan disebut altitude. Okay, you baca soalan betul-betul. Sekejap. Okay, kalau soalan kata altitude. Kenapa dia keluar tu? Okay, kalau soalan kata altitude, means that it's the height from the surface. From the surface to the position of the test mass. Bukan daripada center. You jangan careless. Altitude is height from surface. Okay? Kalau soalan bagi the position of the test mass from the center. Kalau from the center of the mass ataupun the center of planet A, planet B, center of Pluto, tak kisahlah kan? Center of the, apa yang saya tulis ni? The center of the earth. So R, okay, dia adalah daripada sini. You baca betul-betul soalan. R dia mesti daripada sinilah. Ini. This one, the value of R, berapa meter? From the center of the earth. Okay. If the question state that the position of the satellite is at altitude of, for example, let's say given that the altitude is 5 kilometer. This 5 kilometer bukan nilai R. This is the position of the satellite from the surface of the point mass. Okay. So R must be equal to the radius of the earth. Kalau case soalan tu dia bagi earth lah. Kalau dia bagi planet Pluto punya radius lah. Okay. Plus the altitude, H. Boleh? Okay, good. That's why Sebab ada yang tanya saya, they still confused. Mass yang dekat sini ni apa, madam? Okay. Kalau soalan bagi you the mass of the satellite and calculate what is the gravitational field strength, okay, here kita nak kira, contoh kita nak kira what is the, so we want to calculate what is AG here, what is the gravitational field strength at this point. Awak masukkan nilai ini mass of the satellite, salah. Okay. So when we derive the equation, okay, as we know, Fg is equal to MAG kan? Therefore, AG is equal to Fg over M. Tengok ya. M here, I put as a small m, and this is the mass of the test mass. The satellite punya mass. Okay. So, AG is equal to GM M over R squared. Okay. Kalau you tengok dekat equation dalam nota, you ada capital M and then you ada small m. Okay. So the small m is the test mass. Sebab ini ramai yang confused. So hari tu ada yang tanya saya, kenapa dia tak dapat jawapan? Okay. So dia silap kat sini. Okay. So this is Fg over M. M kecil ni. Nampak tak? Saya cancel. Therefore, the equation of the gravitational field strength is Gm over R squared. Bila you dalam exam, you confuse. M ni M apa? You ada dua mass. Mass of the earth as a point mass or mass of the satellite. Okay? So you masuk sini mass of the satellite, you akan salah. Ingat. Okay, good. Okay. Apa lagi? Okay. Okay. Ini semua formula saja kan. Okay, this is the formula. Okay. Satellite motion in a circular orbit. So how to calculate what is the velocity of the satellite. So after derivation, saya tak tunjuk derivation ni. Okay. And then what is the time taken for the satellite to complete one revolution? Okay. Asalnya daripada sini. Okay, awak tengok ya. So ini you punya Earth. So the satellite orbiting the Earth. Satu-satu duduk kecil, satu duduk besar. Macam tu. Okay. So the satellite is moving in a circular motion. Okay. They start from A, moving and back to A. Okay. Remember, V is equal to D over T. Okay, general equation for velocity. Tak nampak? Tak sikit. Okay. So now, what is the distance travel for one complete revolution? Satellite tu bergerak sini, A, patah balik. Satu lilitan bulatan, you belajar maths. It's 2 pi R over T. Okay. So for one revolution, T ini saya tukar kepada T huruf besar. Therefore, T is equal to 2 pi R over V. Ada yang tanya, perlu ke kita guna formula ini? Kalau kita dah ada, okay, kalau you dah ada nilai R and then you ada nilai V, you can straightly proceed to calculate the period of the revolution. Okay? Sebab dia derive daripada sini, nampak tak? 2 pi R over V. V ini, kalau you dah kira dekat sini, you masukkan saja. Tak semestinya guna yang ini. Boleh. Okay, tapi saya rasa tak ada masalah sebab formula diberikan. Okay. So escape velocity, ini derivation. Okay, jangan lupa. Okay. Last one. Ni soalan konsep lah. Okay. So from zero. Macam mana nak buat Okay, saya pusing Saya buat circle. Okay. Alright. So this is Allah kena bilang. Okay. So ini adalah RE. So this is on the surface. R is equal to RE. Okay. And here, jauh sinilah. Dekat point X kita namakan. Here R is bigger than R of the earth. Okay. And here R is less than RE. Okay. So now what is the relationship between R and AG? So when the position is, okay, when inside the earth, R is less than RE. Okay, kat sini. Saya namakan point A and point B. Kalau you ada soalan ratio, you kena tahu. Point A ke point B? Gravitational field strength lagi besar. So this one is inside. Okay, R is less than RE, so inside the earth. So means that the gravitational field strength at point B lagi besar daripada gravitational field strength at point A. Okay, pada keadaan ini, okay, AG is directly proportional with R. Okay, so semakin jauh daripada center, the gravitational field strength you akan increase. Boleh? Okay, good. Sekejap Sekejap ya. Okay. But on the surface, this is on the surface. Okay. Kita tukar kali purple. Yang purple ni on the surface. When R is equal to RE, the gravitational field strength is 9.81. And semakin jauh, semakin keluar daripada surface, semakin jauh lah kan. Semakin jauh. Saya namakan ini adalah point X and this is point Y. Sekejap Okay. Point Y. So gravitational field strength at point Y semestinya lagi kecil, smaller than gravitational field strength at point X. Okay, so you must know the relationship and the graph. Okay, boleh? Okay, good. Okay, you kena tahu baca graph sebab kita tak tahu soalan tu kadang soalan bagi graph suruh you interpret ke? Kan? Okay, so mesti faham. Okay. Sekejap saya kena check. Okay, next. Tadi chapter berapa? 7 kan? 8, 9. Okay, 9. 9 tadi ke atas. Okay, this one. Okay. Okay, look at here. Okay, so now, kecil Okay, so now look at to the definition of the simple harmonic motion. Okay, so defined as periodic motion without loss of energy, which acceleration is directly proportional to the displacement. Okay, acceleration is directly proportional to the displacement. Okay, this is the displacement, the yellow color, and the red color is the acceleration. So directly proportional means that if X is bigger, A also bigger. Awak ada pendulum, you tarik lagi tinggi, what happened to the acceleration? The acceleration will increase. Okay, but the direction of the acceleration is directed towards to the equilibrium. Okay, so tengok sini, the negative sign because the direction is opposite direction with X. Contoh awak tarik ke kanan. Okay, the pendulum is moving to the right. Okay, the yellow color. And now the direction of the acceleration must be to the left, negative x. Boleh? Okay, good. Kalau you bergerak, you tarik you punya pendulum to the left. Okay. So x you akan dapat negative and a you akan dapat to the right. Okay. A you akan dapat negative x. So a you akan dapat positive value. Okay. So positive value because the direction is to the right. Boleh? Okay, good. Okay. And you must know that amplitude is the maximum displacement from the equilibrium. Okay. So, saya padam. Okay. So, here, okay, the bob of the pendulum is moving to the right, means that, let's say this is the maximum displacement. So, this is positive A. And this is negative A. Suka saya ingatkan, okay, awak kena ingatlah. Okay, at maximum displacement, ingat tak awak selalu ingat, awak selalu hafal, at maximum height, V is equal to 0. Okay, so here, at maximum displacement, V is equal to 0. Same goes to this one. Okay, but at equilibrium position, V here is maximum. Okay. And how about the acceleration? Okay. At maximum displacement, acceleration is maximum. Same goes to this one. But here, it's equal to 0. Boleh? Okay. Good. Okay. So this is all the equations in simple harmonic motion in chapter 9. So x, okay, this is omega, the angular velocity, okay, and make sure when you calculate in this chapter, make sure your calculator change to radian mode. Tadi you dah jawab chapter 2, 3, 4, 5, 6, 7. Okay, you punya calculator dalam degree kan, sebab you kira, you resolve you punya vector. But bila you sampai soalan chapter 9, make sure your calculator in radian mode. Okay, sayang you buat dah betul, tapi you salah, jawapan you salah sebab you tak tukar. Okay, so this one V. Okay, so V is when we differentiate dx over dt. Okay, and equation of V ada dua, iaitu in terms of t and in terms of, this one is V in terms of time and this one is V in terms of displacement. Okay, same goes to acceleration. Okay, we differentiate dv dt. Okay, so this is in terms of t and this is equation of acceleration in terms of displacement. Okay, so this is formula for potential energy. Ini jangan lupa. K is equal to m omega squared. Therefore, U is equal to kx squared. Pernah jumpa kan? U is equal to half kx squared. Okay. And K is equal to half. Tengok sini ya. K is equal to, so this one, at x is equal to 0. Okay. K is equal to half m omega squared A squared. Okay. So you kena tahu relationship ni. This is K. So the kinetic energy is equal to half K A squared. Okay. When x is equal to 0. Okay. Kalau U pula dia terbalik. Okay. Nak guna color lain lah. Color ini. Okay. Untuk U, at x is equal to A, which is maximum displacement, U is equal to half KA squared. Saya gantikan ini. Nampak Nampak tak ini dengan ini sama. Okay. This is when X is equal to A and this one X is equal to 0. That's why when you sketch your graph here, the value here is E is equal to half KA squared and this is U. Ingat balik tadi? Okay. Untuk U, when X is equal to positive or negative A, U is equal to half KA squared. Okay. But for K, kinetic energy, when X, saya tulis kat sini ya. So here, kinetic energy warna biru kan? Patah balik. Okay, here. Here when X is equal to 0, and then the kinetic energy is equal to half KA squared. Okay, ini. Okay, dua ini, you kena tahu konsep dia kat situ. Okay. Okay, and we have phase shift. Okay, ada lagi 5 minit sebelum 4:30. Okay, now look at to the graph. Sekejap saya kena check. Okay. So now look at to the graph. The general equation of displacement graph. The general equation of the displacement graph here. X is equal to A sine omega t. Okay. So this is a graph sine. So macam mana you nak sketch graph? So if the condition of the question state that at t is equal to 0 second, x is equal to 0, then we have the general equation of x in terms of sine. Ini graph sine. So kita lukis macam biasalah. Okay. X is equal to 0, t is equal to 0. So we gonna have sine graph. Okay. Tanya diri awak, you pandai tak baca graph? Macam mana kalau soalan bagi graph dan you nak keluarkan maklumat daripada graph? Okay. So for one complete oscillation, 1 lambda. So here, so this is the value of t. Somehow the question not give you the value of t. But let's say the question give you here is 2. So automatically sini mesti 4 second. Okay. And the maximum, tengok pada graph. So this is graph X. Kalau graph X against T, ini adalah maximum displacement. Kalau soalan bagi graph V against T, nilai yang tertinggi dekat sini adalah maximum velocity. Okay, remember. Okay, maximum velocity. Here, V maximum, tengok sini. Okay, V maximum when X is equal to 0. Okay, so kita masukkan nilai dia. So tengok pada graph lah, so ini graph X against T. Kalau soalan bagi you graph X against T, nilai ini adalah maximum displacement. Kalau you ada graph V against T, this is maximum velocity. Kalau ini graph A against T, here is the value of A maximum. Okay? Alright. Okay. So now let's say this one is the phase shift. Okay. Let's say at T is equal to 0, the object is start from positive A. Kan? Kalau you ada spring, macam ni kan? O, negative A, positive A. Maknanya You tarik dulu sampai positive A and then you release the spring. Okay, so here the position, the starting point at T is equal to 0 second. Okay, the starting point is positive A. So graph awak, you akan start daripada positive A lah. Okay, ini yang berkaitan dengan phase shift lah. Saya tunjuk sikit saja, saya tunjuk ini saja ya. Okay, so the original tadi apa? The original graph sine. Okay, kalau soalan bagi you equation, let's say dia bagi you equation ini. Okay, A sin omega t plus pi over 2. So this equation is in terms of sine, right? So how to sketch the graph? Okay, so remember the original, ini equation sine. So the original graph of sine is this pattern. Okay, macam ni ya Allah. Maaf. Kenapa lah sangat? Okay. So, when x is equal to at positive A, okay, so kalau kita ada equation ini, pi over 2, positive pi over 2, okay, positive pi over 2, the y-axis here, okay, you shift your y-axis to the right. Positive pi over 2, you shift your y-axis to the right sebanyak, okay, by pi over 2. Ini pi, this is pi over 2. Okay, you gerakkan ke kanan. So it start from here. Okay, jadi if we have equation of x equal to A sin omega t plus pi over 2, bentuk graf dia dah bukan macam ini lagi. Okay, so bentuk graf yang baru dia, sebab kita dah shift to the right tadi, dia akan jadi macam ini. Nampak? Merah juga. Biru. Boleh lah. Okay, so dia akan jadi macam ini. Nampak tak? So now the graph start from positive A. At t is equal to 0 second. Okay, so now x is equal to positive A. Okay, dia dah tak start daripada kosong. Boleh So ini kalau x is equal to, at t is equal to 0 second, x start from 0. So betul lah dia start from 0 here. Boleh Okay. Yang lain tu awak kena tengok lah. Okay, so this is the equation. I don't think you have problem for, okay, for this one. Make sure mass and K, L, okay, in SI unit. Kalau mass mesti dalam kg lah. Okay. K, apa K? Newton per meter. Okay. Apa lagi? Ni awak boleh baca lah. Okay. So this is a graph V against T yang saya cakap tadi. So the equation of graph V against T. Sekejap ya. Okay. So now, kat mana tadi? Oh, this one. Okay, so V is equal to A omega cos omega T. So, ini graf apa? Kenapa dapat cos pula? Okay, sebab kita differentiate. A, x equal to A sin omega T. V is equal to dx over dt. So, it's equal to A omega cos omega T. So, this is the amplitude of the graph. Amplitude of graph V against T. Okay, so sini. So macam mana pattern graph cos? Okay, so ini equation cos. So the pattern of the graph should be like this lah. Sekejap, saya betulkan sikit. So this is T. For one complete oscillation, okay, T is the period lah, the time taken to complete one oscillation, this one. Okay. Boleh? Okay. So here is the maximum velocity. Bukan maximum displacement. This is maximum velocity. Kalau soalan tu letak sini nilainya 10 and then dia bagi you frequency. Calculate amplitude. You ambil sini nilai 10 meter, amplitude is equal to 10 meter, salah. Okay? This is not the amplitude. This is the amplitude of gravity. Okay? Tapi dia bukan maximum displacement A. Okay? So now, since V maximum is 10 and frequency is given 2 Hertz, then you can find 2 pi f. Omega is 2 pi f. So baru you boleh cari A. Ingat ya, you tengok betul-betul graf tu graf apa. Okay? So now when we differentiate equation V, A is equal to dV over dt. So it's equal to negative A omega squared sin omega t. Okay? So this is the graph sine. So this is a graph sine, tapi ada negatif dekat depan means that the graph of inverse sine graph. Okay? Kalau graph yang asal macam ini, okay? So kalau negative sine, mesti terbalik. You pun tahu kan? So for one complete oscillation, this is T, the value. And the value here, and the value here is the maximum acceleration. Okay, maximum acceleration. Boleh? Okay, good. Okay, so kita dah sampai ke penghujungnya. Okay, saya minta maaf sebab tak dapat cover semua. Okay, tapi saya akan sharekan link untuk awak download nota ni untuk awak baca malam nanti. Saya ucapkan selamat maju jaya dan semua yang hadir pada hari ini dapat jawab dengan tenang, dengan mudah. Jangan buat silap, jangan careless, baca soalan betul-betul, tukar unit, letak unit, itu saja. Okay, so untuk pelajar-pelajar saya, jumpa lagi. Okay, jumpa lagi di second semester. Okay, okay. Madam, bila masa nak guna positif or negatif A? Okay, kalau soalan tu bagi condition. Sekejap satu sebelum habis. Saya dah bagi ucapan dah tadi. Sekejap satu-satu. Okay, kalau soalan bagi contoh pendulum lah kan. Sini O, equilibrium position. Kalau tarik ke sini, A dia positif ke negatif? To the right kan? So ini positif A. Tengok pada soalan. Okay? So sini adalah, dia benda yang sama. Magnitude dia sama, direction saja yang berbeza. So ini negatif A. Same goes to spring. Positif A, kosong. Okay, kalau you compress, macam tu. So, this one is positive A. You tarik to the right, so the maximum displacement is positive and this one is negative. Okay? So, itu saja untuk hari ini. Saya minta maaf tak dapat cover sampai habis. Saya dah cuba selaju yang mungkin. Mungkin kalau kita ada lagi 2 jam, kita boleh habis. Okay? So, thanks to all. And jangan lupa dapatkan nota ni adalah daripada saya sebut tadi daripada pensyarah Kolej Matrikulasi Johor, Puan Nina Farina binti Syahzarin. Okay, semoga dimurahkan rezeki, okay, dan awak semua pun dapat jawab dengan mudah. Okay, so boleh go through nota ni malam ni ataupun you ada nota sendiri, you boleh guna. Okay, so itu saja untuk hari ini. Terima kasih. Assalamualaikum dan selamat sejahtera. and good luck. Bye-bye.